Welcome, everybody, and thank you for joining today's webinar, Choosing the Right Point Cloud Processing Strategy, hosted by Q Plus Labs and 3D Systems. I appreciate you joining us today. This webinar is the first in a series of webinars, so please be on the lookout for future invitations from Q Plus Labs. A few housekeeping items before we get started. As you may have noticed, all attendees' lines were muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. Although we will not be addressing questions live during the webinar, we will follow up with you afterwards with an answer to your question. In a couple of days, you'll be receiving a follow-up email with a link to view the recording of this webinar, as well as additional materials related to the content being shown today. Once again, thank you for joining us. And now I will pass it on to Spencer Keene, a Geomagic application engineer, as he will be leading today's demonstration. Spencer, it's all yours.
Thank you, Q Plus Labs, for having me today. My name is Spencer Keene, and I'm an applications engineer for 3D Systems. In today's webinar, we will be discussing the 3 different reverse engineering techniques used to obtain a solid model from scan data. This solid model can later be used in a downstream CAD package. We will be using 3 different Geomagic softwares to achieve this. In Geomagic's Wrap, we will be creating an auto surface solid model. In Geomagic for SOLIDWORKS, which is a SOLIDWORKS plugin, we will be doing hybrid modeling. Hybrid models use auto surface modeling and parametric modeling together. This is important because you are not able to use auto surfaces for an assembly constraint. In Design X, we will be modeling parametrically. Then we will run a full history tree live transfer into a CAD package. By transferring the model's history tree, you are then allowed to make design changes in your CAD software. Okay, let's get started. As you can see, we are already in Geomagic's Wrap. In the display window, you can see that I've already imported the scan data provided by Q Plus Labs. The physical artifact that was scanned does not have a bottom surface. And in order to create a solid model, we are going to have to do some mesh editing. Usually to start a project, we would have to align the scan data to the world's origin. Since we're aligned, I have my predefined views. And over in this toolbar, we have our selection tools. I'm going to use the circle select, make sure select through is on. Select this cylinder and hit delete. Go over to the next feature. Select my rectangle selection. Select this slot and hit delete. To the next feature, I will do my lasso selection. And delete. Now that I have this data cleaned up, get this noise here real quick. I can go in and fill holes. Go to my fill holes tool, make sure flat is selected, and come fill in these boundaries. And zoom in and check the results. Everything looks good. If you notice on the bottom, we have a little roughness going on. Then if we filled that hole here, we would have a pretty rough looking mesh there. So what we're going to do is create an offset plane from our XY plane and do a trim. We're going to go into features, our plane offset. We're going to select our XY plane and give it a value of 20 thousandths. and hit apply. Looks good. Okay. We'll go back into our polygons tab, our trim tool, trim with plane. Select our plane we created, intersect plane, delete selection, close intersection. Very fast, we were able to get a smooth, flat bottom plane here. Hit OK. Bring our model back into view. Now that we have a watertight mesh, before we do any surfacing, let's run the mesh doctor. The mesh doctor will go out there and see if we have any bad polygons. As you can see, we have 14 self intersections, 45 highly creased edges, some spikes. So what we're going to do is hit apply, and this should zero out all these numbers here. It's very important to run the mesh doctor when you're doing auto surface. It helps the software organize its NURB surfaces better. Once we're zeroed out, we're going to hit OK. And now we have a watertight mesh. We're going to go into our exact surfaces, run exact surfacing. And instead of doing a straight auto surface, which automatically creates a NURBS model with minimal user interface, we're going to run detect contours. Detect contours places red separators between regions of relative flatness, and then contour lines will be placed inside those separators. Okay, let's go ahead and run detect contours. Let's hit compute. So let's make sure our select through is off. And let's go around the part and see what we have. If we want to add a separation, left mouse click. Let's add another one here. If we want to set our rotation center, we can do that by right clicking. Now we can rotate about the plus. All in all, the software did a good job. So we're going to hit extract. And you'll see our contour lines be placed in those red separators. Let's hit OK. And now we have to go in and see if we have any problems going on with our contours. So we're going to go into Edit Contours. I'm going to set my rotation on the plus again. And let's see what we have. So we would want one coming down here. Just go into this draw line. Start it here. Bring it down. Now I can adjust this. Looks good. I want another one here. And adjust. All looks good. I'm going to set my rotation again here. To delete a line, you hold Control. I'm going to drag this to the corner. I'm going to add a line here. bottom. Add another one here. I can bring this down to the bottom there. Bring that one down. I'm going to delete this contour. Delete this contour. And then I'm going to merge these two. I have to add one more across. A little reorganizing. Okay, everything looks good. Let's hit OK. Now we're going to construct patches. Construct patches generates a patch boundary structure from the contour lines that we've created and also the boundary lines. So let's hit OK. Auto estimate. Apply. Okay, now we have our patch network out here. Everything looks good. Hit OK. And now we can do a few things. We can do repairs or shuffles. For this demo, we're going to go right into construct grids. Construct grids creates an ordered UV grid in every patch on the object. Hit apply. So resolution, if I had that number lower or higher, the higher you go, the more tight knit these patches are and the more accurate they get. So you can see there's 20 patches inside each NURB. That looks good. I'm going to hit OK. We're going to go into fit surfaces. Fit surfaces generates a NURB surface on the object. I usually like to run constant. Control points. The more control points, the more accurate we get. We can hit apply. Okay. And now we have a solid file. If I turn on my surface boundaries and the display tab, we can see that. So let's go in and run a deviation. Deviation generates a three-dimensional color-coded mapping of the differences between the solid model and the scan data. We're going to hit apply. And I'm going to change the tolerance values. These are specific to your company's standards. So for me, I'm going to run plus or minus 4 thou, and then the min max is going to be 40 thou. Okay, I'm going to come in here, 3 decimal places, change the max to 40 thou. Bottom one, negative 40 thou. Four thou. And negative 4 thou. And as you can see, very accurate by doing the auto surface. Everything looks good. Once I get to this point, I can save this out. So hit OK. And I can save this out now as an IGES or a step file. Now that we have finished auto surfacing in Wrap, let's walk through the hybrid modeling workflow in Geomagic for SOLIDWORKS. I will now open up SOLIDWORKS. As you can see, I have already imported and aligned the data. In order to create a hybrid model, one that contains auto surface data and parametric data, I will need to make a copy of the mesh and fill in the features that I will later on parametrically model. How I do this is by right-clicking on the mesh in the tree and hitting duplicate. I'm going to hide the original data and edit the copied data. Now that I'm in edit, I can right-click and tell the software what selection tool I want to use. Polyline works well here. First, I have to remember to have select through on. Select through. Hit delete. And move on to the next feature. For the slot, I like to use the rectangle selection. Hit delete. And move on to the next feature. I'll go back to the polyline. Delete. So I like what I got. I will accept this. And I typically like to run the detached triangles tool. I show you over here, there's a little bit of noise. So now I will fill holes. I'll make sure my flat fill is on. I'll select these boundaries. Toggle to the backside. That looks good. Now that we have a watertight mesh, we're going to run an auto surface. We'll have mechanical and adaptive set, and let this run. Now that I have my auto surface data, I can now build planes to take cross sections to generate sketches that I can extrude cut with. If I hide my mesh and show my edges, you can see that we have an auto surface solid. I want to hide my auto surface and pull up my original mesh data. I need to build a plane, so I will extract reference plane. I'll use my smart selection tool, hit OK, and I've generated a plane. Now that I have this plane, I can open up cross sections, tell it to use the plane I used. It will project 4 thousandths down. You can see a little preview there. I want to use my smart selection tool, curve option, make as. line and arc. And tell the software just to take the cylinder section. Preview. Say OK. Now I have to edit that sketch because I did not have full data in that cylinder. So I'll right click, edit sketch, right click, normal to. I'll hide my mesh, zoom in. I'll add a point at the center of this diameter. I will do a power trim. And I'll add my own circle. And I could give it a dimension call out here. For the purpose of this webinar, we'll save this. So I'll exit my sketch. And I'll open up my auto surface. And I'll go into SOLIDWORKS features now. Extrude. I'll highlight my mesh and I'll go into extrude cut. And I'll say both directions and apply. And now we have our first machine surface that we can use in an assembly constraint. Let's go on to our next feature. We'll hide the auto surface. Turn on our original mesh. Go back into Geomagic for SOLIDWORKS. Extract a reference plane with our Smart Selection tool. Accept that. Now we have our second plane that we will use to build this slot. We'll open up cross sections again. We'll say that we're using this plane. It's going to take a cross section at a depth of 4 thou. We have our curve options, make as, line and arcs. And then we'll say our limited selection with our smart tool. We'll hit this side wall of the slot. Toggle around preview. And we'll accept. Just like last time, we might have to go in and edit this sketch. So we'll right click, edit, right click, normal to. We'll hide the mesh. Come in. Notice how that's not closed. So we'll have to do a little bit of editing here. Okay, I'll have to build separate lines here. And we'll go back and constrain these again. Tangent. Tangent. And I'm just, like I said, clicking on one, holding shift, holding the other. Just like you would in SOLIDWORKS. Now that we have a constrained sketch, we can exit sketch, turn on our auto surface, and go into SOLIDWORKS features. Extrude cut. Let me highlight the mesh first. Extrude cut. It's going one direction. Let's say also the second. Hit OK. And you see we have our second machine surface. Let's hide our mesh or our auto surface. Open up our mesh data. And go back into Geomagic for SolidWorks. For this last feature, we have these smart extraction tools. I'm going to use the extrusion tool, and once again, say our smart tool, click in here, hit OK. And this gave us an extrusion. I'm going to have to delete the extrusion and use this sketch back in features in in SolidWorks. Extrude cut. Both directions. Say OK. I didn't have my auto surface turned on, but it still made that cut. We can view that now. And I'll hide my... Okay, so maybe I'll have to do that over. So I'll have the sketch, extrude cut, both directions. So it seems that you have to have the auto surface open for the extrude cut to work. Now that we have our hybrid model completed, let's run a deviation analysis. I'll go back inside of Geo for SolidWorks. In order to get my toolbar lit up again, I have to show my mesh. And I can go to deviation analysis, select mesh, select body, and preview. I want to change my tolerances to 4 thou. And as you can see, we are very accurate to the part once again. That concludes our hybrid modeling workflow inside of Geomagic for SolidWorks. And now we will be modeling a fully prismatic feature tree inside of Design X. In Design X, we have the capability of doing all three of the workflows. But for today's webinar, we're going to be parametric modeling. So our new interface in Design X 19 pretty much allows you to complete the whole workflow in the Home tab. So let's start it off. Right off the bat, we're going to do a thing called auto segment, which creates regions by considering curvature flow. I'll let this run. And what you'll see is that the software allocates geometric features to the mesh. So a plane's a plane, cylinder's a cylinder, a cone's a cone. And I'll show you this by hovering over the colors. You'll see a plane here, sphere, plane, cone. And we use these regions to help our modeling process. So how I look at parametric modeling is basically like machining a block. I like to get my main stock and cut away from that. So in doing that, we're going to select this plane, select mesh sketch, take a section of nice data, hit OK, hide my mesh, come in with the rectangle sketch, and we can snap to this pink polyline. When I like what I have, I'm going to exit out of the sketch, and I'm going to open up the extrude tool. I'm going to extrude past the part because I'm going to use a surface to trim out that top section. So hit OK, hide my solid. Now we're going to do a thing called a mesh fit. A mesh fit uses the surface below to design a very accurate surface. I want to orient it like I would want the surface to be oriented. I'll hit next stage. At this point, I can turn on the accuracy analyzer and see how accurate I am to my underlying mesh. I can add control points here by holding control. So once I'm happy with that, I'll accept. I'll turn on the solid and surface body. I'll go into my model tab and I need to extend this surface outside of the solid body. That looks good. I'll hit accept. And I'll use my cut tool. My tool is my surface data. My target's my main body. My remaining is the bottom portion. As you can see, we're already starting to take form. I'm going to hide my solid, and I'm going to use my region plane to create my next sketch. So I'll highlight that. I'll go back to my home tab and say mesh sketch. I'm going to bring my section into nice data, hit accept, hide my mesh. This time I'm going to use a tool called the auto sketch. Auto sketch is a very powerful and fast tool, and it allows me to make sketches with constraints very fast. So I'm going to resize this so it's outside of the main block. I'm going to close up my sketch. All right. Exit the sketch. Turn on my solid. And this time I'm going to do an extrude cut. I tell it to cut. Hit OK. Now let's move on to the next feature. Maybe this one over here. So right now that doesn't say plane. So I'm actually going to go and build my own plane. I'm going to hide my region. And just like in Geo for SOLIDWORKS, we have a smart selection tool. Take a look. Say OK. Now we're going to use plane 1 to build a sketch on. So highlight plane 1, go into my mesh sketch. As you can see, when I take a section of this, it's going to take a section of the data that I want, but it's going to project the sketch back to plane 1. So I'm going to hide my mesh. I'm going to do an auto sketch again. Really fast, constrained data. I do a resize. And close this sketch up. Exit, turn on my solid. And once again, I'm going to do an extrude cut. Say OK. Now that I had CAD surfaces, I can use those to design sketches on. So if I hide my plane and I'll use this CAD face, I'll say mesh sketch. And I'm going to drag this down into the mesh where that cylinder lies. I'm going to say OK, hide my solid, and snap a circle. In Design X, I can dimension things. Let's say I wanted this to be 3.5. Hit exit. Turn on my solid. And this time I need to extrude both ways and do a cut. Nice. All right, let's move on to our next feature, the slot. I'll turn my regions back on, and I'll highlight this plane. My sketch. Bring the section into some nice data. Hit OK. Turn off my mesh. And I'll use the slot sketch tool. And I'll window in this slot, accept this, fully constrained. I'll exit out, turn back on my solid, and I'm going to do another extrude cut. I'm going to use my CAD face, do a mesh sketch, drag it down into the nice data, accept that, hide my solid, window in my slot again, accept it, exit the sketch, turn the solid on, and we're going to do an extrude cut in both directions. Hit accept. And let's head on down to the next feature here. I'm going to use my plane, mesh sketch, drag into nice data, use my auto sketch tool, accept that, do a resize, close up my data, accept it, exit, and we're going to do another extrude cut. We're going to use the CAD face, do a mesh sketch. I'm going to drag it down into some nice data, accept that, hide my solid, and I'm going to use my slot tool again, window that in, hit accept, exit the sketch, and another extrude cut in both directions. Accept this. Oop, forgot to hit cut. So I just right click, edit, cut, accept. At this point, we could do a deviation check. And as you can see, we're very accurate to the underlining mesh. If I hover over certain areas, it will give me an actual value. Turn that off, and now let's do these revolves here. So in Design X, we have a very cool tool called the Revolve Wizard. We also have the Extrusion Wizard, a Loft Wizard, a Sweep Wizard, and a Pipe Wizard. And what these wizards do is they use the mesh data to generate solid models. So when I open the Revolution Wizard up, I'm going to tell it that we want the sphere, the fillet, the plane, fillet, and the cone, and press next stage. As you can see, it generated a plane, a vector, and a sketch, and then did a revolve, all by just telling it what regions we needed. So I accept that, but I will have to drag the sketch into the part. So I'll go to Edit Sketch, and I'll just drag this down into the solid. And I'll hit Exit. You can preview the revolve we made. So let's do that to these next two. Revolution Wizard. Next stage. A plane, a vector, a sketch, and a revolve. Very fast. I'll have to drag my sketch into my main body. And one more time. Now that I have the main data, I'm going to start adding some fillets. Hide my planes. Go into the Model tab, open up the Fillet tool, and let's do this top surface first. In Design X, we have an Estimate Radius from Mesh tool for fillets, which is very nice. Let that run. I'll accept that. And do these sides, corners. I'll hit the Estimate tool. Accept. And you notice if I have this lock highlighted, the tool will not quit itself after I accept. We could have gave a specific value for those. I just kind of wanted to show you the tool there. And then maybe our last here. Estimate. Hit OK. We can run another deviation. As you can see, we're very accurate again. The deviation analyzer can be customized. So when I have my model fully modeled, the goal is to get it into a CAD package. In Design X, we have a thing called live transfer. If I scroll down here, we can live transfer into SOLIDWORKS, Creo, Inventor, NX, AutoCAD, Solid Edge, and we can also export as a CAT part. For this demonstration, we're going to live transfer into SOLIDWORKS. I'm going to say start from the first feature, and in the background, SOLIDWORKS is going to open up, and you're going to see my full history tree be built inside of SOLIDWORKS. And so when this is finished, now my SolidWorks project is fully editable. I can make design changes. Very cool. So let me hide my surface. And we have our parametric model in here. And I can go in now and say if I wanted to edit this sketch, so on and so forth. Well, thank you, Q Plus Labs, for having me today. I hope I was able to pass on some knowledge. I'm going to give it back to you guys at this point. Have a nice rest of the day. Goodbye.
Thank you, Spencer. This brings us to the end of today's webinar. As I mentioned when we got started, although we won't be taking questions live, please feel free to enter any questions you may have in the Q&A section on your screen, and we will be sure to follow up with you with an answer to your question. Or, if you'd like to talk to somebody right away, you can contact Q Plus Labs at 949-380-7758, or you can email us at sales@qpluslabs.com. In the coming days, each of you will receive an email with a link to the recorded version of this webinar, along with additional materials related to today's demonstration. Finally, as this is the first of a series of webinars, be sure to be on the lookout for invitations to future webinars from Q Plus Labs and 3D Systems. Thank you again for joining us, and have a good rest of your day.